In the last video, we talked about a story that Danny and Peter found a design pattern called Safe and Smart Lock to make the mutex safer in a multi-threading environment. If you haven't watched that video, you can watch it here or down below. In this video, we are going to tell a new story that is about a new design pattern called condition variable. It is designed for one thread to efficiently wait for some conditions. Let's continue to use our story to explain this pattern. So now Danny and Peter decide to make the Blackboard more useful in real life. Now Peter will keep updating the stock price in real time onto the Blackboard. And Danny, while working in office, will occasionally pick at the Blackboard, and if he sees the price is higher than $90, he will sell his stock. The problem for Danny is that he worries to miss the opportunity to sell the stock. Why? Because what if Peter updates the stock price to higher than 90, say $99, and because of the market fluctuation, it drops down to $80 shortly. If during this time Danny didn't watch the Blackboard, he would miss the opportunity to sell the stock. So how to resolve this problem? By keep watching more often on the Blackboard is not a solution at all. Because number one, Danny has a work to do. He cannot spend all his time to watch the stock price in office. And number two, no matter how often Danny watches the Blackboard, it's still possible for him to miss the price. So we put all this story into the code. So now our Blackboard will become a structure which has a price and a stock name. And Peter will be responsible for updating the price onto the Blackboard. And Danny will, in a loop, keep looking at the price. So now Peter's thread will hook up with the Peter update stock function, and Danny will hook up with Danny's read stock function. And let's run the code to see what happened. And we ran the program twice. And the first time, Danny did get a chance to sell his stock. But the second time, Danny just missed the opportunity. So it's a hit and miss. So these results shows that the polling strategy doesn't work in this situation. So what is the answer? So Danny figured out a solution. So he asked Peter, hey, Peter, since you are updating the price, right? If you see the price is higher than $90, why don't you just give me a call and let me know so that I do not need to keep watching the Blackboard all the time. I will do my work all the time and don't even look at the Blackboard until you notify me. So this is the core concept of condition variable. So now Danny represents the waiting thread who is waiting for the condition of the price is higher than $90. And Peter now is the updating thread who is responsible for updating the condition. And once the condition is satisfied, he will be responsible to notify Danny. So Danny is waiting for the condition, and Peter is responsible for notify Danny that the condition is satisfied. So this is the core concept of the condition variable. Fortunately, C++ provides a class called condition variable. We can use it directly. So the first thing we need to do is to update our Peter update stock function. We added a secondary parameter of condition variable reference. So we will use this condition to notify Danny that the price is higher than $90. So how do we do that? So after we update the price, we will check if the price is higher than $90. If it is, then we will unlock the safe, and then we will print out the message, and then we will call the notify one function on condition. This is how we notify the Danny thread that the price is higher than $90. and then we will sleep for a few milliseconds, and then we will lock the safe back again. So now let's take a look at what the Dennis function is. So we will create a new function called Denny wait and the stock price function. And for this function, we will pass in the safe as the first parameter and a condition variable reference as a second parameter. What it does inside this function is that as you use, Danny will lock the Blackboard, the safe, and then it will print out message saying, I'm going to wait. And then it will call the condition variables wait function. What does this mean is that it does three things. Number one, remember Danny now has locked the safe, right? So once it gets into the wait function and we pass the lock object as a parameter to the wait function, the first thing the wait function does is to unlock it so that when this thread, the Danny thread, is waiting, other thread will have the chance to get the lock and lock the mutex so that they can do their things. The second thing wait will do is after it is released the mutex, it will go to sleep and consume almost 0% of CPU. And the third thing the wait function does is that once Peter notifies this condition, and Danny's thread will wake up, and the first thing it wakes up is to in step one. So after this line of code finish, or after we exit wait, the Danny thread gained the log of mutex again. So after this line of code, we already have the mutex. So let's continue to the next one. So after we get the log of the safe, then we will acquire the safe resource. So and then we will print out the stock price and we will sell at this price. This is how Danny's thread is doing. So let's go back to Peter's thread. So now you understand why we need to unlock the mutex before we notify the condition or before we notify Danny, and then sleep for a few milliseconds and then lock it again. The reason is that when we notify Danny's thread, we need to release or give up the mutex so that in Danny's thread, in the wait function, it can gain the mutex. And the reason why we put Peter's thread to sleep before it can lock is to give the chance that the wait function in the Danny's thread actually can get the mutex. That's it. So let's write our test function. Of course, we will create our safe, and of course, we will create our conditions that can be shared by both Peter and Danny's thread. So as usual, we create Danny and Peter's thread, pass a respective function and the parameters, and then let them to finish, and then let's see what happened. So we put this function into our main function, and let's run the code and see what happened. So we run the code, and we see the prince of Danny is waiting, and Peter updates the price to $7. It's lower than $90. Danny didn't wake up. Updated to 73, still lower than $19. Danny didn't wake up. And updated to $99. Now it's higher than $19. See, and Peter notified Danny. And now Danny get notified and sold his stock at $99. So now we can see how condition variable works. There's some more details you can learn. For example, when you wait, you probably don't want to wait forever. There's a wait for function that you can specify how long you can wait. If you wait longer than that period of time and still haven't got notified, you can time out. Another logic is that it's always a good practice to, when you wake up, you check the condition again to see if it's a false notification. This is something that happens quite often. So wake up and recheck the condition. If it's met, you do your thing. If it's not met, you go to sleep and wait again. So this is a good practice. In fact, there's another version of the wait function which accepts a second parameter. This parameter allows the wait function to check if the condition is met or not. If not, the wait function will continue to wait, saving you from write your own logic to wait again. So I will put a link of the document under the video. You can learn those details from the link. Multithreading is an important part of software architecture design. If you want to systematically learn software architecture design, you can check out my online course here. Let's continue our story. As Danny becomes good at selling one stock, he starts to buy more and more stocks. But he discovers that managing 20 stocks means managing 20 condition variables. This is apparently not sustainable. In next video, you will find out how Peter and Danny find a smart solution to solve this problem. I put the next video here or put the link down below. This channel is all about digital transformation and technology. If you are interested in these topics, please join our community down below, where you can discuss these topics with other people with the same interest.